Hello, everyone. So now I see most of our guests are already joining this webinar. So now I will announce that the webinar will start. As I mentioned previously, if there's any questions, please kindly type into the question box, and we will answer these questions in the Q&A session. Now, we will move into next agenda, SB101A6 Product Feature Introduction and Showcase. This session will be presented by Alan Tai, the System Product Line Manager from AIC. Alan, it's all yours.
Welcome to join AIC webinar. My name is Alan Tai. I am in charge of AIC Platform Solution Group Product Management. And today I would like to go through AIC SB101A6 product highlights with the following agenda: product positioning and application segments, system key features, system design view, and comparison between SB101A6 versus previous SB101 UR. SB101A6 is designed with the feature of large memory and CPU core counts for the applications as HPC, hyperscalers, scale-up analytics, financial, and scientific research. SB101A6 was launched with Intel Victory platform this year. Then we are going to have a Valorant offering for mainstream use cases by SB101 Tucana and SB202 Tucana. System key features: dual Intel Xeon 3rd generation scalable processor, Ice Lake SP in ATX form factor motherboard, 32 DDR4 3200 megatransfers per second RDIMM LRDIMM supported, 2 PCIe Gen 4 full height half-length add-on cards plus 1 OCP 3.0 hard swappable module, 43.5 PCIe Gen 4 NVMe SATA SAS tri-mode backplane, 2.5 slim 7mm SATA drive bracket plus 1 M.2 socket 2280 SATA NVMe, 8 high-performance swappable system fans, high efficiency 800 watts redundant power supply, system dimensions in depth 800, width 438, and height 44 mm. System design with both 3.5 hard swap hard drive base, USB 3.0, LEDs and buttons in the front, and 2 PCIe Gen 4 by 16 full height half-length card slots, OCP 3.0, management ports, USB 3.0 ports, VGA, COM port, and power supply on rear panel. ATX form factor motherboard to support Intel 3rd generation scalable processors, Ice Lake SP, 40 cores per processor, up to 80 cores in a 2x configuration, support for 85 watts to 270 watts TDP, 3.6 GHz highest base frequency, Intel Turbo Boost Technology 2.0, hyper-threading, speed shift, and enhanced Intel speed step technology supported. 8 high-performance swappable system fans with optimal airflow for cooling, 32 DDR4 RDIMM LRDIMM by 8 channels, 2 DIMM per channel, DDR4 up to 3200 megatransfers per second. Support for up to 6 terabytes of system memory per processor. Up to 12 terabytes in a two-socket configuration. Support for Intel Optane persistent memory 200 series. Up to 4 terabytes of processor. Up to 8 terabytes in a two-socket configuration. 64 lanes of PCIe Express 4.0 per processor. Total 128 lanes in two sockets. Each PCIe Gen 4 lane is providing up to 64 gigabytes per second bandwidth and is also backward compatible with prior PCIe generation devices. Two PCIe Gen 4 full height half-length cards on easy swappable brackets. One OCP 3.0 hot swappable module slots. Four 3.5-inch PCIe Gen 4 NVMe SATA SAS tri-mode backplane with UBM LED controller. Two 2.5 slim 7mm SATA drive bracket plus one M.2 socket 2280 SATA NVMe. High efficiency 800 watt hot swappable redundant power supply. Optional 1200 watts for 270 watt processors. CRPS module with 80 plus platinum level efficiency. Full range AC 90 to 264 volt input voltage. Hot swappable design for maintenance. Motherboard with built-in 1+1 redundant PDB. One U with depth 800mm provide a compact size of system to fit into 1 meter rack cabinet. A comparison of SB101UR versus SB101A6. Thanks for your time to join AIC SB101A6 webinar today.
Thank you, Alan, for the introduction. Now, let me play a demo video of SB101A6 to showcase the great features of the model.
For hot swappable two-less trays, it supports either 2.5 or 3.5 SATA SAS and NVMe drives. Poor card design for system serial number labels. Two USB 3.0 ports, reset button, ID indicator, alert LED, power indicator, and power button. Two less top cover design. Two internal 2.5 easy swap drive bracket for SATA drives. 8 high-power hot swappable system fans. Dual Intel Xeon 3rd generation scalable processors and 32 DDR4 DIMMs. Two full high half-length easy swappable card bracket and OCP 3.0 slots. High efficiency 1+1 redundant power supply 800 watts modules.
Now, we are entering the last session of this webinar. Let me transfer to Vincent Lee, who is Cloud Business Development Director of AIC, for him to share a success story of SB101A6. Vincent, please take it away.
Hello everyone, I'm Vincent, working on AIC Cloud Business Development Department. Take this chance, I will be very happy to share how we work with DC-grade customers for their pain point discovery and solving loss requests as much as we can. For one example, DC-grade customers who only get the 5 engineers ready in their ICE team to do the maintenance around 14,000 server nodes in their data centers every day. How to maximize each engineer working efficiencies will be serious subjects always. Also, in order to ensure the cloud service continues without interrupt by end of the same day, no chance to do troubleshooting and detailed check-ins by next day more hour times, always. Even though the vendors will dispatch the service engineer for hardware maintenance into the data center, but due to security control, it is not allowed. Many people stay inside together. It means the more convenient server design will be helping customers to do the quick work all the times. After study customers' expectations, AIC come out some conclusions here. The new generation platform design should be involve customers' needs always. It will ensure satisfying and business success in all parties without disappointment after large deployments. For helping customers to maximize manpower efficiency purpose, toolless design have to be applied every corner. As a large deployment inside of data center, it should be easy to identify the specific servers against maintenance purpose. The last point, all cabling should be done well organized and keeping safe at the proper place against any purpose. First of all, main solution founder should discuss with the customers to find out one best suitable CPU SKU on both specifications and cost-wise adjustments. Once the CPU SKU is defined, AIC will perform the following job to select all proper components such as CPU heatsink, cooling fan, and the power supply modules to make sure system can be running smoothly at the most economic configurations. And in the next generation's new compute node platform design, AIC is helping customers to ensure multiple storage devices can be used, such as 3.5-inch SATA HDD, 2.5-inch SATA HDD SSD, and 2.5 NVMe SSD. More than this, all type devices are supporting toolless as a request. This page is showing some toolless design, which really appreciated by customers. AIC's design creative is enlarge the server's utilizations on same storage device carrier with more type storage device applying possibilities. Through the converting kits, either 3.5-inch or 2.5-inch can be loaded on the same carrier by hand without any tool use, which is holding strong without losing as well. Also, all interfaces can be applied, such as SATA, SAS, and the NVMe. As the previous live demonstrations, this page is showing more toolless design, such as internal device carrier, cooling fan, OCP aiding cards, power supply modules, standard aiding cards retainer kits. Our engineer can search the proper servers unit in the large deployment data center room shortly. AIC servers is with the ID tag in front and support the UID LED and the button on both front and the rear sides. Engineer will not miss the specific servers unit, which can find out quickly. Also, based on the resource protection purpose, AC power source will be divided by A and B separate in the data center always. AIC is helping customers to customize the power cord with a proper lens and a different color for easy identifications. In the last, with a minor subject but really important to customers. Customers wish to prevent any cable and expected unplugged situation happening, which include the power cord lock design to prevent server surprise shutdown. This minor design is helping customers to protect their expensive assets actually. All right, thank you for watching AIC latest Intel platform case studies. I will forward the session back to the hosters. For more information, please visit us at aicipc.com or contact our regional sales directory.
Okay, thank you very much, Vincent, for the presentation, and thank you all the speakers. And now we will be entering our Q&A session. So if there's any questions, please type into the question box. And again, I will remind you, the presentation files are now available from the Handout session. You may download it to your local to view. And now I can see there's a one question pop up. The question is, what is the tri-mode back plan? I think this is for our PLM Ellen to answer. Ellen, please.
Okay. The tri-mode pay plan is used to support either SAS, SATA, or NVMe drives on one single pay plan design without changing PCBA or cables.
Okay. There's another question. The customer asks, what if I want to build RAID for NVMe drives? This is also, may I have Ellen to answer this question?
Okay. Users is able to build RAID for NVMe drive by a VRAC upgrade key to enable CPU built-in RAID entry. Or press an additional RAID card is also the alternative.
Okay, thank you, Ellen. This is a great question. Now I can see there's a question regarding the success story that Vincent just shared. The question is, does the 3.5-inch to 2.5-inch toolless converting kit require screw drive to fix or remove the kit from the 3.5 hot swappable carrier? Can I have Vincent to answer the question?
Yes, this is Vincent. In order to meet fully toolless conditions, this converting key itself is also with toolless design. So any person can easily remove it out and then using the same carrier for 3.5-inch storage device loading directly. Thank you.
Thank you, Vincent. This is a great question. And there's another question. What is the purpose to provide both UID in front and rear window? I think this is also regarding the success story that Vincent shared. So can I have Vincent to answer the question?
Yeah, it's me again. The data center is very big when installing thousands of servers inside. So it will divide by many rows and each row may have 20 or 30 racks side by side aligned together. Hence, It will be helpful for engineer to identify the exactly same server when he go around those racks from front side to back side actually. So this is the main reason why the servers need to support UID on both sides. Thank you.
Thank you, Vincent. It is very helpful to understand it. And I can see there is one last question. It's what is the difference between OCP 2.0 and OCP 3.0? This question we should have Ellen Tai to answer. Ellen, please.
Okay. The improvements of OCP 3.0 are hot swappable design and 75 watts class supported. And OCP 3.0 module are PCIe Gen 4 graded devices.
Okay. Thank you, Ellen. I think that is all the questions. If you still have questions that has not been answered in this session, please feel free to contact us or contact the regional sales that we will be very happy to help. With that, I think I will conclude today's webinar is over. So thank you again for joining this webinar. I hope I will see you in next AIC webinar. Thank you very much. Bye-bye.
Bye-bye.